Hello everyone. I hope you all are doing good. This is Lakshmi Narayana, Senior Physics Faculty. Electricity. Okay. The most important topic and related to the real life. The most especially physics is related to the real life only. But without this, without electricity, we can't do any work. Even you not listen the classes also. Okay, so are you excited to follow the classes? Are you excited to hear about the electricity chapter? You all are excited? I am also so excited. Okay, yeah. So without any delay, can we continue? Electricity. Okay, what is electricity? You have an idea about an electricity, right? If any electronic devices has to work, the electricity is required, right? For example, mobile phone, electricity is required. Panel, electricity is required. Camera, electricity is required. Bike, electricity is required. So in everyday life, electricity is also one of the part. Okay, yeah. See, what are the topics we're gonna cover in today's section? What topics are there? What are the topics? We're gonna introduction of charge. Okay, the basic one is that introduction of charge. Then after we will discuss about conductors, insulator and semiconductors. What are these? What are these? What is conductor? What is semiconductor? What is insulator? Okay, so these all are the types to pass the electricity from one place to another place. Okay, next, electrical current and circuit. From here onwards, our section begins. Okay, from electrical current and circuit onwards, our section begins. Previous one, just recapped. Next, electrical potential and potential differences are there. Okay, what is electrical potential? Okay, if current passes from one point to another point, how the potential will be? Is it same or variate? We will discuss in this. Next, circuit diagram. The really circuit diagram is required to pass the electricity or not. Okay, what type of circuit diagrams are there? Whether open circuit or closed circuit, which circuit is required? Next, Ohm's law, the main important topic for further classes also. It will be very useful. Okay, what is Ohm's law? Okay, next, factors on which the resistance of a conductor depends. Okay, if you take what is resistance first of all, okay, you should know what is resistance and what factors are there. Next, summary. Okay, okay, yeah. Next, see, charge. Charge. So many of them know about charge. Okay, what is charge? What is charge? So charge is the basic property. What is charge? It is a basic property. If you take any material, how it forms? It made up of atoms or molecules, right? Any substance like pen, remote, book, table, any material, it's made up of atoms or molecules, right? So in atom, what it is present? Subparticles are present. What are the subparticles? Proton is present, electron is present, neutron is present. Okay, subparticles, where are these present? What it is present? Protons, electrons, neutrons. What is the charge of the proton? Positive. What is the charge of the electron? Negative. What is the charge of the neutron? Neutral charge. Okay, charge is what? It's a basic property. Okay, it's a fundamental property of matter. It's a fundamental property of matter. There is no matter, no charge. No matter, no charge. If you need charge, the matter has to present, either solid or liquid or any other. Okay, so matter present, charge is also present. No matter, no charge. Okay, if definitely charge is required, matter is present. The matter is present without charge also, that is possible. Okay, matter present means charge is present. Without matter, no charge. But with matter, if the matter is present, the charge is not required. Charge is now what? It's a fundamental property. Charge is what? It's a fundamental property. Okay, or intrinsic property, because it's present inside only. Intrinsic property. Okay, it is intrinsic property. Protons, electrons, neutrons exhibit electrostatic attraction or repulsion in the presence of other matter with charge. Attraction is present. Okay. Repulsion is also present. Which particles attract? Opposite charge particles are attract. Same particles repel each other. Same particles repel. One positive, another positive repulse. One positive, another positive repulse. Okay. Positive, positive repel. Negative, negative repel. We know na. Okay. Which particles attract? One positive, one negative. Both attract. Okay. Both attract each other. Next, what is the SI unit of electrical charge? Remember, SI unit of electrical charge is coulomb. What is that SI unit of electrical charge? Coulomb. CGS unit is ESU, electrostatic unit. Okay, we have two units. SI unit, CGS unit. SI unit is what? Coulomb. CGS unit is that electrostatic unit. Okay, ESU. In 1 coulomb, how many electrons are present? 6 into 10 to the power of 18 electrons are present. How many electrons? If I am taken a body, okay, I am taking a body. I am taking A is a body. On this body, let us consider 1 coulomb charge is present. How much charge is present? 1 coulomb. 1 coulomb. Charge is 1 coulomb. 1 coulomb charge is present. In this 1 coulomb of charge, how many number of electrons are present? How can we calculate? We have a formula of quantization of energy. Q is equal to Ne. Q is equal to Ne. Remember, Q is equal to Ne. Charge. Q is what charge? How much charge particle? 1 coulomb charge. Number of electrons that we don't know. N. Electrons. 1 electron is 1.6 into 10 to the power of minus 19 na? Minus 19 na? Then n value you will get 1 by 1.6 into 10 to the power of minus 19. Then you will get 6 into 10 to the power of 18 electrons in 1 coulomb of charge. If anybody asks you, in 1 coulomb of charge, how many electrons are present? How many? 6 into 10 to the power of 18 electrons are present. Okay, next. 1 electron as a negative charge, that is 1.6 into 10 to the power of minus 19. Okay, 1.6 into 10 to the power of minus 19 coulomb. 1 electron. In 1 coulomb, 6 into 10 to the power of 18 electrons are present. Remember. Okay, in mathematical calculation it will be helpful. Next, conductors, insulators, semiconductors. What is conductor? What is semiconductor? What is insulator? Okay, conductors means which allow the charge. I am a conductor, not means not giving a ticket. Okay, conductor means if I touch the electrical board, the electricity passes through my body or not. If it is passes, I am a conductor. I act like a conductor. Okay, if it is not passes, I am an insulator. If you see any persons doing a work, electricity work, what they will wear? Gloves they will wear, right? Chappals they will wear, right? Why? Because it's an insulator. Insulator means doesn't allow. Conductor means allows. Okay. Conductors means allow. Conductors means allow. Insulators do not allow. Opposite, completely opposite. That way electrical persons wear always insulating materials. If you see a wire also, okay, a copper wire, it coated with insulating material. Okay, insulating material is there. Okay, the insulating material is protection from the electrical shocks. Next, semiconductor. Semi means of, allow of, Allow of stop off. Okay, allow of stop off. Okay, so we have two types of semiconductors, silicon and germanium. And insulator we have many. Rubber is there, plastic is there. Okay, so these all are insulators. Wood is also insulator. Next, conductors means all metals. Conductors means all metals. All metals are act as a good conductors. Okay, metals, conductors means allow. Insulator means completely opposite, doesn't allow. Semiconductor means allow, off only. Off only. For suppose 10 amperes of current passes, it allows 5 amperes. Remaining 5 amperes doesn't allow. Okay, like that. Remember. Next, electrical current. Okay, what is mean by electrical current? For example, I am taking a one material. I am taking a one material here. This is the area of that material. Area of that material. Okay, charge is entering into the material. Okay, charge entering into the material, and here it is that leaving the material. Here it is enter. Here it is exit. Okay, entering time t is equal to 0 seconds. Leave the time t is equal to t seconds. Okay, in time of t seconds, what is the charge? Charge will flow na. Charge passing through unit area, right? Here I am taking a conductor. Charge passing through unit area. Charge passing through unit area is called electrical current. Okay, what is electrical current? Flows through a conductor. We say that there is electrical current in the conductor. Okay, if the electrical charge, which charge? Electrical charge. Electrical charge flows through the conductor is called electrical current. Simply current means flow. Current means flow. Okay, current means flow. Which is flow? Charge is flow. The charge flow through unit area is called current. Simple. Electrical current. Electrical means charge. Current means flow. Electrical current means charge flow. Electrical current. Simple. Okay. Or else we have one more also. Electrical current is amount of charge. Amount of charge, particular unit area in unit time. Let us see here. How much time taken? In time of t seconds. Okay. How much charge? Amount of charge. Charge per unit time. Charge per unit time is called current. Charge per unit time is called current. Okay. Look at the formula. The rate of flow of electrical charge. Charge per unit time. Charge unit, coulomb. What is the unit of charge? Coulomb. What is the unit of time? Second. Coulomb per second we call as ampere. Okay, remember. Coulomb per second, what we call? Ampere we called. Coulomb is what? It's a unit of charge. Second is what? It's a unit of time. Coulomb per second. Coulomb, charge per unit time. Charge per unit time. Take a conductor. Charge passing through the conductor. And how much time taken? T seconds. This charge per this time, you will get the current, the flow in the conductor. For example, if I got electrical shock, charge passing through my body. Okay, charge passing through my body. How much time taken? For example, let's take less time. If you take more time, that's it. Okay, just take less time. Because if current passes continuously through my body, what will happen? Guess. What will happen? My nervous system will completely back, right? Completely doesn't work na. Okay, so if someone help me to live. Okay, so how much time? Let us take 2 seconds. 2 seconds charge passes. Charge passes 2 seconds. That is called current. Electrical current. How much time, how much current passes through my body? How much charge is present in a given time? Okay. Next, unit. What is the unit of current? ampere. What is the unit of current? Ampere. Okay. Next. Electrical current is defined as flow of charge. Okay. And unit ampere only. 1 ampere. 1 ampere. 1 ampere. 1 ampere means 1 ampere. Ampere is what? It's a unit of electric current. Ampere is what? It's a unit of electrical current. So electrical current formula is what? Coulomb per time. Coulomb per time. LHS value is how much? LHS value is how much? 1. Then 1 equal to LHS equal to RHS na. It means 1 coulomb of charge per 1 unit of time. Simple. LHS is 1, RHS also same only. 1 ampere is nothing but 1 coulomb of charge in a 1 second of time. Simple. 1 ampere. If you want to get 1 ampere current, 1 coulomb of charge in a 1 unit of time, you will get 1 ampere current. Clear? Next. The instrument measured. What is the instrument? If current passes through the body. Okay, let us take, this is a wire, current passing through the wire. How can I calculate? I will hold it. Okay, 2 coulomb charge passes, 4 coulomb charge passes. Can I calculate like that? Is it possible to calculating like that by holding a body? No, right? Okay. So, what is the device we use to calculate the amount of current? What is the device we will use? We will call as ammeter. What is the name? Remember? Ammeter. Okay, ammeter. So this ammeter is help us to find out the current in a given circuit. Okay, for example, I am taking a one circuit here, one battery, and circuit having a resistance. If current is passing through the circuit, how much current is there? I would like to calculate how much current is present in the circuit. How can I calculate? I will put an ammeter. Then by the ammeter, I will calculate how much current is present in the circuit. Clear? Next. In a circuit using metallic wires, electrons constitute the flow of charges. Which are constitute? Electrons are constitutes in metallic wires. Why? In metallic wires, more number of free electrons are present. Okay, highly free electrons are present in a metals. Okay, in metals, highly free electrons. Free electrons means it's comes out of the atom. It comes out of the atom. Okay, if you take an atom, this is the nucleus and this is the outermost cell. This is the outermost cell. If the electron is present in the outermost cell, which electron present in outermost cell? This electron we called valency electrons. Valency means outermost cell. Okay. For example, if this electron comes out, the electron comes out from the valency cell. These electrons we called free electron. Okay, free electrons means the electrons comes out of the. Okay, I am a free bird means there is no responsible, nothing is present. Free bird, it's completely free. Enjoy. Okay, see, metallic wires, more what it is present, more number of electrons present, highly present, consisting of electrons. Okay, electrical wire not known at the time when the phenomenon of electricity. Okay, when discovered electricity, at that time there is no chance to find out an electron. Later they discuss. Okay, next, electrical current was considered to be the flow of positive charge. When they know, before they don't know about electricity, flow of electrons. Okay, later on they know it. That's why they consisting that electricity is the flow of positive charge. and direction of flow of positive charges was taken to be direction of electrical current. Okay, if electrical current is passes, if electrical current is passes through a given wire or a conducting wire, it connected to the battery. Okay, what we will consider? What we will consider? Electrical current. Electrical current. Okay, current having a direction na, electrical current as a direction. How can you represent this direction? How can you represent this direction? The direction you represent the positive, okay, flow of positive charges. Okay, flow of positive charges. See, from the positive terminal, the flow will be there like this, positive, positive to negative. Okay, the flow will be positive to negative. So this positive charges flow is considered as electrical current. Okay, the positive charges flow is considered as electrical current. Remember, if someone asks you what is the direction of electrical current, what is the answer? The positive charges flow is the consider of electrical current. And what about electrons? Electrons also present na? The electrons travels opposite direction. See, this direction positive charges will be there means opposite direction negative charges are present. These negative charges what we called electrons, which are present with the negative charge, electrons only na. So if positive charges are going like this, electrons are going like this, both are opposite. Okay, if you represent the direction of current means we have to consider positive, because from the earlier onwards we are taking only positive. Okay, what about electrical current? That is opposite direction of positive current. Clear? Yeah. Next, so electrical current is taken as opposite to the direction of flow of electrons. Okay, flow of electrons. Electrons started with the negative terminal and going opposite direction to the positive terminal. Okay, next, see, an instrument called ammeter. What the ammeter will do? It measures amount of current present in the circuit. We already discussed. Okay, the device measuring that how much current present in the circuit is that ammeter. Okay, how ammeter is connected? How ammeter is connected? The ammeter always connected in series. Remember how the ammeter connected? The ammeter is always connected in series. All of you may have doubt. Okay, you also get from chat box, sir, why ammeter is connected in series? I said na, you will get a doubt, right? So from the chat box we get a doubt why ammeter is connected in series. See, first of all, series connection means what ma? Series connection means I am taking a one bulb. Okay, this is the bulb symbol na? Okay, and I am attaching one more bulb here. How connected? End to end. End to end. So the connection is end to end, then it will be series. Remember, series means end to end connections. End to end connection. For example, I am taking a one cell in a torchlight, positive terminal, negative terminal. One more cell connected here. Again positive terminal, negative terminal. One more cell I connected here. Again positive terminal, negative terminal. How the connection will be? Positive, negative. Okay. Positive, negative, positive, negative, positive, negative. Connection will be see. Positive, negative, positive, negative, positive, negative connected na. So it is called end to end connection. Okay. What is mean by end to end connection? Connecting alternately, positive, negative, positive, negative, positive, negative, end to end connection. How the ammeter is connected? Always in series. Remember, star mark given. Ammeter is always connected in series. Okay, because ammeter measures amount of current present in the circuit. Amount amount. Where you calculate amount? In a total circuit, na? If you want to get a total circuit current, means the ammeter always connected in series only. Okay? Ammeter always connected in series because you are getting the total amount of current through the circuit. How much current? How much current? Okay. For example, if I am taking a divide into two path, if I divide into two path, okay, how it will be? Here the current is enter, right? Here the current is I1, okay. Here the current is I2. So at this point O, current divided, na, current splitted into two parts. If I connected ammeter, I will get this current only. If I will connect ammeter here, I will get this current only. Okay, so if I need total amount of current through the circuit, okay, how much flow will be present in the circuit, then it means I have to connect always in series. Always connected in series only. Okay, always connected in series. With the resistance also, you will connected in series only. Next, electrical current flows from positive to negative terminal. Okay, electrical current where to where it go? Positive terminal to negative terminal. Positive terminal to negative terminal. Okay, next, look at the question. Look at the question. Get ready for answer. Understand now why we connected ammeter in series. Okay, if you want to get the total amount of current, okay, by the circuit, how much current will be present in the circuit? Ammeter. Okay, for example, in domestic purpose also, ammeter is there na. Okay, to your home, how much current you are getting? Where you will see? Ammeter only. How the ammeter is connected? Where it is connected? Huh? So series only na we connected. We connected ammeter always in series. If you want to get the total amount of current. Okay. Next, look at the question. Write the given information. Write the given information. A current. How much current? Current means flow. Current means flow. Okay. How much flow is there? 0.5 amperes. Where the flow will be? Drawn by a filament of an electrical bulb. So let us take a bulb. I am taking a bulb. I am taking a bulb. Okay. Current is passing na, through the bulb. How much? I. Flow is there. If current passes, bulb glow. How much current? 0.5 amperes of current given to the bulb. What happened next? Bulb for 10 minutes. How much time? Even in my home also, I on the bulb. I switch on the bulb for 10 minutes. How much current is passed? Let us take 0.5 amperes only. How much connected is this? Time is 10 minutes. 10 minutes is switch on only. Bulb is on. Okay. These 10 minutes, 0.5 amperes current is passing. Okay. 0.5 amperes of current is continuously passing for 10 minutes because the current is steady current. Okay. Next, find the amount of electrical charge. So, how much charge is passing that you want to calculate? How much charge is passing that you want to calculate? What is the formula? What is the formula? I is equal to Q by T only na, simple. I you know, time you know, you don't know charge. So Q charge is equal to I into T. Simple. Like that only na. What do you want to find out? Charge. Charge is equal to I into T. How much current? 0.5 amperes. And time 10 minutes. See, 0.5 ampere is the SI unit of current. 0.5 ampere is the SI unit of current. And 10 minutes. So converting into SI units, 60. So 0.5 into 600. It means simply calculate 5 into 60. 300 coulombs of charge. How much charge is present? 300 coulombs of charge flows through the bulb. That's it. Okay, how much charge? If I am connected ammeter here in a circuit series, how much it will show? How much current it will show? That 300 coulombs charge passing. 300 coulomb charge passing, and how much current in the ammeter? 0.5 ammeter shows in a ammeter. 0.5 ammeter. Okay, 0.5 amperes current shows in the ammeter. Next question, define SI unit. We have two units, SI unit, CBSE unit. SI unit of electrical current. Electrical current formula what? Electrical current flow per unit time, flow coulomb, okay, time second, coulomb per second, ampere. So ampere is the SI unit of electric current. Simple hai na, right? Very simple. Okay, next electric potential, electrical potential. So this topic is little bit clumsy. Okay, don't confuse. Okay, don't confuse, focus the class. Then if you have any doubt, you can comment in the chat box. I will help you to explain the answer. Okay, electric potential, electrical potential. Every person having some potential, right? You are also having some potential, I also having some potential. Okay, so how can we calculate that potential? For example, if I am running, okay, 100 meter, if I am running 100 meter, I am taking for that 100 meters, I am taking 10 seconds. Is it possible? Okay, let us think. Okay, I am a Superman. So 100 meters travel in, let us take 5 minutes. 100 meters in 2 minutes. The same 100 meters you traveled in 1 minute. Who is more potential? You or me? Anybody from comment section? Sir, I have more potential. See, they have more potential, right? So how can you calculate the potential? What is the work and how much time you take into completing that work? That is the calculating the potential. How can you calculate the potential? How can you calculate the potential? Work done. Simply power you take, work done per unit time. You have more power. Okay, see here which potential? Electrical potential. Electrical potential. What it is doing? Amount of work done. What they calculating that? Amount of work done carrying which charge? A unit positive charge. Carrying a unit positive charge. For example, I am taken a plus Q naught. It's a point charge. Which charge? Point charge. Which charge it is? Point charge. Yes, ma. Yeah, from comment sections are what is point charge? What is point charge? So point charge is nothing but, for example, if you are seeing me very near a distance, how I will be? How I will be? My height is this much. Okay, you can see, right? If I will travel, if I will move 10 meters, how it appears? Little small I will appear. If same I will travel 20 meters, what happened? Size will be decreases now. So where I will appear like a point, that means if you are seeing a long distance from me, if you are seeing me from a long distance, how I will appear? Like a point, chota wala, right? So point. So here point charge is nothing but the charge also the same thing. If I am saying that a point charge is nothing but compared to the size. Okay, compare the distance with respect to size, it will be less. Okay, for example, I am standing here. If I am going away from the A, you are here, I am going away from the A. What happened? At somewhere I will appear like a point now. How I appear like point? Because this size, a dimension of the body compared to the distance is very less. That's why it is appearing like point. So here also point size is nothing but distance will be more, much greater than the size. So that's why it is a point charge. What we are doing? This point charge, we are working on this point charge. What we are doing? Working on this point charge. Where it is? Where it is? It is at infinity. Where it is the point charge? It is at infinity. From infinity to, there is some charge. Let us take Q plus capital Q. Okay. There is some charge plus Q. From infinity to some distance, let us take. From infinity to some distance, we are bringing the charge from here to here. What we are doing? We are doing work. What work we are doing? Bringing a unit positive charge from infinity to a point under an electrical field. So this body is having electrical field now. This body is having electrical field, right? So this is the electrical field of this body. Okay. So in this electrical field we bring. For bringing from infinity to at a point, okay, at a point in the electrical field, from infinity to this point, how much work you are doing, that is called potential. Okay, simply potential is nothing but what? Working on a point charge from infinity to at a point in the field, that is called potential. Okay, next, an external electrical force. How it will become? By external electrical force only, na? Next, potential is which quantity? Scalar quantity. Potential is which quantity? Scalar quantity. See, potential. How the potential will be scalar? Anybody get it out? Yes, in comment section I already have a comment. Sir, how potential will be scalar? Have a doubt, na? See, how potential will be scalar? Potential is nothing but what, ma? Work done per unit charge. Okay, I am taking a Q naught is a point charge. On this point charge, I am doing work done. That is called potential. That's it only, na? Potential is nothing but on a unit point charge, I am doing work. What working? Bringing from infinity to at a point in electrical field. This is called potential. Work done is what? Work scalar only. Work is what? Scalar only. Charge, that is also scalar only. Scalar by scalar. Potential is also scalar only. Clear na? Very simple. Okay? Very simple. Next. What makes electric charges to flow? What makes electrical charges to flow? So you may not get this kind of doubt. Okay? You may not get this kind of doubt. Why electrical charges are flow? Huh? Have you get this kind of doubt whenever you're studying about electricity? Anybody? Anybody from comment section? No, sir. No one get this kind of doubt. Okay. See, for example, let us take this is a tube. What is this? What is this? Comment sections. Sir, it is a remote. Assume. Okay. Assume. What is this? Assume it is a pipe. Okay. Horizontal pipe. Water is passing through the pipe. See, if I hold like this with the same height, if I hold like this, water will be there. Okay, this is also open, this is also open. Which side water flow? Which side water flow? Water will flow? Never. Water will constantly present. Water will constantly present. See in comment section how it will be. Sir, if you use more water, it will flow. No, my dear. Take less amount of water only. Okay. I am taking a very less amount of water in a pipe. If I will be like this, what happened? Water flow this side, right? Or if I will tilt like this, water flow this side. So what happened? Water is flowing. When height difference is there, then only water is flowing. Okay, if height is, there is no difference in height from the surface, same height, right side also, left side also same height. If there is same height, there is no flow of water. Okay, if difference in height, either this side or this side, it will go. Understand now? So even electricity also same thing only. If charges flowing means here no height difference. Here potential difference is there. Here potential difference is there. For example, if I am taking a battery, if you buy a battery, they will mention 20 volts. What is this 20 volts? Ma? If you buy any electronic device, they will mention a voltage, right? They will mention a voltage. Na? So, how you calculated that voltage? What it gives that voltage? That it is nothing but, okay, here it is positive terminal, na? Here it is negative terminal. Na? So, positive terminal have higher potential, negative terminal as lower potential. Where to where charge go? Higher to lower. It means here what difference is there? Potential difference is there. Because of this potential difference, charges go from higher potential to lower potential. If I am taking a pipe, where to where go? Here to here, because this is more height. So higher potential to lower potential. Okay, electricity charges moving means because of a difference of electrical pressure. Difference of electrical pressure is called potential difference. Okay, charges doesn't flow by itself. Remember, when it is connected to the battery, then only the flow will be there. Okay, when it is connected to the battery, then only. Otherwise, if you are not connected to the battery, I am taking a one metal wire, charges will be there, but there is no movement. Clear? Next, the difference of potential may be produced by battery. Okay, how the potential difference comes in a electrical wire? Because of battery. Okay, a battery connected means what the battery will do? Doing a work on charged particles, moving a charge from one end to another end. This is the work done by battery. Okay, next, the potential difference set the charge in motion. See, very important point. Very important point. If there is a potential difference, this potential difference allows the charge is in motion. See, if height difference, then only na flow will be there. Here, if potential difference is there, then only the flow will be there. Clear? Next, and produces an electrical current, right? So we define the electrical potential difference between 2 points. How can you calculate it? If charge is going from one point to another point, let us take this point is A and here B. Charge moving from A to B na. At A one potential, at B one potential. So here potential difference is there. Okay, potential difference is there. If you think at A potential is VA, at B potential is VB, potential A is equal to potential B means there is no flow. Okay, there is no flow. When the flow will be there, potential difference is there, then potential flow will be there. Okay, next, work done to move a unit charge from one point to another point, what we call electrical potential. Okay, electrical potential, potential difference and potential, remember very carefully, a small difference is there. Potential means from infinity to at a point. Potential difference means if you take a circuit between any 2 points in the circuit, A to B or B to A, at any point potential difference will be there na. That potential difference, okay, that is the potential difference at any 2 points is in a circuit, that is potential difference. From infinity to at a point, that is potential. The potential means infinity to at a point. Potential difference means any 2 points in a circuit. Between that two difference we call potential difference. Next, potential difference is equal to work done by charge. Work done unit joule, charge unit coulomb, charge per coulomb we called volt. Charge per coulomb, we call it is that volt. Okay. Next, it's a SI unit. Next, 1 volt. Previously 1 ampere. Now 1 volt. Okay. Previously 1 ampere. Now 1 volt. 1 volt means volt potential formula. Work done per unit charge na. Work done per unit charge. 1 volt. How much you require? 1 volt. It means 1 into V. How much LHS? LHS is equal to RHS na. Anybody? Yes, in comment section they are very fast. Sir, 1 unit charge, 1 joule of work. It is called 1 volt. 1 coulomb of charge. 1 coulomb of charge. On 1 coulomb of charge, we are doing 1 joule of work. Okay, and 1 coulomb of charge. For example, this remote is 1 coulomb of charge. Okay, I am moving 1 coulomb of charge. On this 1 coulomb of charge, how much work I did? 1 joule of work. That is called 1 voltage. Simple. 1 by 1. 1 only. 1 joule per 1 coulomb. It is called 1 volt. Okay. Next, potential difference is measured by means of instrument called voltmeter. How the current will be measured? Ammeter. Current measures ammeter. Potential difference measures voltmeter. Ammeter, how we connect? Series. Series means end to end connection. Voltmeter, how we connect? Voltmeter is always connected in parallel. Remember, you will get 2 questions. Okay. Ammeter, how we connect? Series. Voltmeter, how we connect? Parallelly connect. Okay. How connected? Parallelly we connected voltmeter. Okay. That means if you take in a 2 circuits here. Okay. So if I need to get difference between A to B, how I connected to the circuit? How I connected to the circuit? If this is a circuit, how I connected it is? How I connected it is that? Okay. See, how I connected here it is that? How it is? Parallel. Okay. How we connected voltmeter? Voltmeter always connected in parallel. Ammeter always connected in series. Okay. Next, how much work is done in moving a charge of 2 coulombs across 2 points. Let us take 2 points. I am taking A. Okay, 2 points. A is 1 point, B is 1 point. A to B, what I did? How much charge from A to B? From A to B, how much charge from A? It is having 2 coulombs charge. At B also, from A to B, I drag the charge 2 coulombs. Okay, from A to B. At A is there, at B. Okay, from A to B, how much charge? 2 coulombs of charge moving from 2 points, A to B. How much potential is applied moving from A to B? How much potential is applied? How much potential? 12 volts. Okay, here A to B, I moved a charge. How much work I done here? That I would like to calculate. How much work I did here? That I would like to calculate. Formula: voltage I know, work I don't know, charge I know. Then W is equal to voltage into Q na. Voltage 12, charge 2, 12 to 24. So 24 joules of work is required moving from A to B. Okay, is having a 12 volts of potential. Clear? Next, circuit diagram. Okay, really the circuit is required or not? Circuit is required or not? If I would like to go from one place to another place, what it is required? A path is required, na? So similarly here in circuit diagram also The circuit is nothing but it's just like a path. Okay, just like a path. See how what are the components are there? Battery is present. What are the components are there? Battery is present. Through the battery, current is passing, and where it gone? Here it is. A bulb is connected. When the current is passes, bulb glow. See how the ammeter. What is a ammeter? How the ammeter is connected? See, plus negative. Okay, again plus negative. How it will be? End to end connection. If it is end to end connection, which one it is? Series connection. Okay, series connection, and K is the plug key. K is the plug key. See, a graphical representation of electrical circuit. Circuit diagram is nothing but it's a graphical representation. Okay, if it is not graphical, if I would like to draw a bulb, maybe for you it is possible. For me, it's not possible to draw. For many members, it's not possible to draw all the diagrams like switch, okay, resistors and bulb. So many electrical components, it's not possible to draw the diagram. That's why we follow that graphical representation. For suppose here, by seeing this symbol, seeing this symbol, what we can assume in our mind? What we can assume? There is a bulb. Okay. Yeah. Next, look at the symbols. Look at the symbols. Look at the symbols. Okay, remember that. Important to know the symbols also. Sometimes you need to draw the circuit diagrams also. Okay. Electrical cell. Cell means one positive, one big terminal, one small terminal. One big terminal, one small terminal. Next, battery. Battery is nothing but combination. It means plus, minus, plus, minus, plus, minus, plus, minus. It's battery only. Combination of cells, battery. Okay, remember, cell is a single, battery is a plural. Okay, combination. Next, switch open or plug key open. See, look at the difference. Here there is a dot. If dot present means it's closed. If there is no dot means it's open circuit. Okay, switch on, switch off, both will be there now. On means circuit is closed. How can you represent? Okay, for suppose there is a switch here, I on the switch. How can you represent the diagram? With a dot. Open means no dot. That's it, simple. Next, wire joint. If you joined any 2 or 3, see, point, joint. Okay. If crosses the wire, one by one, crosses means this is the symbol. Okay. Next, electrical bulb. See, symbol. If the bulb glow means like this. Next, resistor. Resistor. If you know the resistor means that symbol, it come automatically in our mind. Okay, in our mind we will get automatically. What is the functioning of resistor? Opposing. Okay, opposing the movement of electron. If you are going on a road, what will be present? Speed breaker. Like this only, na? Like this only. What will do? Control the speed. Control the speed. So this is the symbol. Here resistor symbol also the same. Next, variable resistance. Variable resistance. So if you go in road also, sometimes I speak. Okay, speed breakers will be like this. Like this only, sometimes speed breakers will be. See, if bike is going here, movement will be slow. And coming to here, compared to A, it be some better. Compared to B, it C some better. Compared to C, it D better. So, how the flow will be? At different points different, right? So, here also variable resistance means the current flow will be different. Okay. Next, ammeter. Symbol you know, A. Voltmeter. Symbol O. Okay. Next. Ohm's law. Very, very important. Okay, in introduction also we said Ohm's law. It's very important. Okay, if you understand Ohm's law, based on that Ohm's law, we have numericals, okay, and concept based questions. Okay, can we start the Ohm's law? Yes. See, Ohm's law is what? Relation between current, voltage, and resistance. How many variables are there? Three variables: current, voltage, resistance. Relation between among these three. For example, I am taking a one conductor. Okay, let's connect it to the battery. Okay, when connected to the battery through the circuit, potential difference will be there na. At A one potential, at B one potential will be there. Current is passing, charge is passing through the conductor. Charge is passing through the conductor. This experiment we do that at a temperature constant. Okay, at temperature constant, how much potential? Okay, how much potential difference we given to the wire, that much current will be there. So simply potential difference increases, flow also increases. If potential difference decreases, flow also decreases. Both are proportional each other. Both are proportional each other, because I is what ma? I is what? Flow. Flow where depends? It depends on the source, right? Flow depends on the source only na. Flow depends on battery only, right? If I am taking a 10 volts battery connected to a LED bulb, 20 volts battery connected to the LED bulb, difference is there or not? What difference will be? LED light is same. 10 volts, 20 volts, what difference is there? 10 volts is there, charge flow for time. 20 volts, how the charge will be? Flow is different, right? Okay, if source changes, simply source changes, flow also changes. Source changes, flow also changes. If I am going on a cycle, the flow will be different. If I am going on a bike, flow will be different. If I am going on a car, flow will be different. Okay, so why the flow is changed? Because vehicle changed. Okay, 150 cc, 120 cc, 100 cc, 350 cc, right? So flow changes based on the source. So what is the source here? Voltage is the source. Where this will be happen? At constant temperature. If you remove the proportionality, what you will get? Or you will get V is equal to Ri. What is our resistor? What is our resistor? Look at here, the potential difference V across the end of given metallic wire in electrical circuit is directly proportional. Okay, electrical potential is directly proportional to the electrical potential, directly proportional to the current. V proportional to I. Remove proportionality, you will get a resistor. Okay, you will get resistance. So the symbol of resistance, the unit of resistance is ohm. What is the unit? Ohm. O H ohm. OHM. Ohm, it is the unit of resistance. For example, your friend asks you what is the unit of resistance. Oh, enough. You get the answer ohm. Okay. What is the unit of resistance? Even we are thinking also, we will think that you get sound na ohm. That's it. Ohm is the unit of resistance. Okay, and the symbol is like this. This is the symbol of resistance. Okay. Next, see how the graph will be. How the graph will be. See, what is Ohm's law? V proportional to I. V increases, current also increases. See, current on the x-axis, potential on the y-axis. Potential increases at 0.4. Current also increases. Okay. How it will be? Straight line. How it will be? How it will be? Straight line. If I am taking an angle here, theta. If I am taking an angle here, tan theta is equal to opposite side by adjacent side. Opposite side is what? Opposite side y components only, y1, y2, y3, y4, y components only. Adjacent side x components, y by x. Y is what? Voltage. X is what? Current. So v by I, that is resistance. V by is what? Resistance only. Clear? Okay. See, V by is what? Resistance. So at a given temperature, this all the experiments done at a temperature constant. If temperature varies, means what happened? Whenever we connected, let us take a conductor connected to the battery, and potential difference is created at the end of the conductors, then the flow will be there. This all the things will be takes place on at constant temperature. For example, temperature changes. If increasing the temperature, what happened? The flow is not, it's different, it's changes a flow. Why? If temperature increasing means, for example, if temperature increases, the electrons comes out, right? More number of electrons comes out from the atoms, na? The flow will be changes, the flow will be different. That's why, what is the Ohm's law said? At constant temperature, the given potential is directly proportional to the flow of the current. Okay, remember, at constant temperature only, or okay, at constant temperature, V directly proportional to the flow of the current. Okay, potential difference across the wire increases linearly. This is called Ohm's law. Okay, see how it will be increasing now. Linearly, how the increasing will be? Linearly. How much potential is there? That much current is there. Increasing linearly. Okay, next. 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 How does the current in a circuit changes if the potential difference is doubled? Anybody from comment section? Anybody? Huh? What is the question, ma? What is the question? Solution. Write the given. Write the given. How does the current in a circuit changes? So I am taking a circuit. How much potential? Let us take V. Okay, connected to the bulb. Okay, so if V is there, current is I. Okay, how does the current in a circuit changes if the potential difference is doubled when keeping the resistance is constant? Keeping, what is the formula? V is equal to I R. What is our resistance? What is our resistance? Keep resistance constant as per the question. Keep resistance is constant as per the question. If keeping a constant, what happened? In place of constant, one symbol will come now, proportional symbol. So V proportional to I. V proportional to I. That only in Ohm's law. If voltage increases, current also increases. When? At constant. So V, what is the question? In question, potential increases, then current also increases. How much potential increases? Potential increases twice. Current also increases twice only, that's it. 2V proportional to 2I. If potential increases, flow also increases. Okay, when? At constant temperature or at constant resistance. Clear? Yeah. Next, resistance of a conductor. Resistance of a conductor. So most of them don't know about resistance. Okay, so what is mean by resistance? Okay, in general, if you take an example, you are going on a bike on a road. Okay, you're not having a helmet, someone will stop you, right? Okay, someone will stop you now. They are doing opposition. Our speed breakers will be there. What it will do? If you are going with a high speed, what the speed breakers do? Control the speed, reduces the speed, right? So even if you take a conducting material, in conducting materials also speed breakers are there. Okay, in conducting materials also speed breakers. Electrons are moving in opposite direction, na? Okay, when a metallic wire is connected to the battery, electrons are moving opposite direction to the positive current, right? Opposite direction to the positive current. When electrons are moving, in a metal, positive ions are there. So these electrons come and collided with the positive ions. Comes and collided with the positive ions. So when it is collided with the positive ions, what happened? Its speed reduces. Okay, the electrons movement are opposite. So this property is called resistance. Okay, so what is the property of a conductor? Resist. What resist ma? Flow of charges. Resist the flow of charges is called resistance. Resist the flow of charges is called resistance. So if the potential difference across the two ends of conductor, okay, when it will be 1 ohm, tell me, when it will be 1 ohm, 1 ohm of resistance, V is equal to IR. Okay, R is equal to, we can write V by I na. What we required? 1 ohm. 1 ohm. 1 ohm of resistance we required. Anybody from comment section? Yes, they are very fast. Okay, 1 ohm. 1 ohm means 1 ohm. LHS is 1 ohm. It means RH is 1 volt by 1 ampere of current. 1 volt by 1 ampere of current. Then you will get 1 ohm of resistance. Simple. Okay, if you get 1 means LH is 1, RH is 1. Simple. Okay, next, look at the property. How the property will be? Property of a conductor opposes the flow of electrical current. See, look at that. How the electrons are going like this, in this direction. Electrons are going in this direction. How the opposition will be? Opposite direction. Electrons, if electrons are coming, stop. Shoo. Okay. So, electrons are going, stop the electrons. That property we call it is that resistance. Okay, what is the resistance? Simply opposes the flow of electrical current is called resistance. Resistance unit is what? Scalar only. Resistance unit is what? Scalar. Why it is scalar? R is equal to V by I na. Potential is what? Scalar. Current is what? Scalar. Scalar by scalar. Scalar only you will get. Okay. Next unit ohm. We know it. Next, the moving of electrons. Okay, moving of electrons collide with each other. Okay, moving of electrons, one electron, another electron. Okay, collide. One electron, another electron collided, or the electron collided with other particles also. Electron collided with the other particles. Which are present? Other particles means ions are present na. So it is collided with other particles. That this property is called as that resistance. Okay, positive ions present in the metallic conductor. Okay, itself collided each other and it collided with the positive ions also in a conductor. Okay, next, see, this collision tends to slow down the speed of the electrons. After collision, what happened? For suppose if I am moving, I collide with the bench, what happened? Can I move? I will move like this only, na? I will not move much fast, right? So here also, after the collision, what happened? Slow down the speed of electrons. Okay, hence this slowdown means what? Opposing the flow of electrical current. Look at there. Look at the diagram. If you look at the diagram, you understand better. See, electrons moving, collided with the other electrons or collided with the positive ions. So, what happened whenever the collision takes place? Opposes the movement of free electrons. That property is called as the resistance property. Whenever temperature increases, what happen? Whenever temperature increases, what happen? Okay, if the temperature increases, electrons move much fast now. Electrons move much fast. Electrons move much fast. Then collision takes place. Maximum number of collisions takes place. High number of collisions takes place when temperature is increases. Clear? Next, what are the factors resistance depends. What factors resistance depends? Resistance mainly depends on three factors. Okay, it depends upon the length, okay, and it depends upon the area of cross section, and it depends upon the nature of material. Okay, if length is L, if I extended, resistance changes. If area is A, if I extended area, resistance changes, or decreases the area, resistance changes. Okay, and if I'm taking a plastic and wood, resistance will be differ, right? Resist, if we are having same length, this is also L, this is also L, this is also A, this is also A, but look at the nature of the material also. This is wood, this is plastic, both are same nature? No, then resistance will be differ. Okay, what are the factors of resistance? Depends on length, depends of area of cross section, depends upon the nature of material. Okay, remember LN, Lakshmi Narayana sir, me only. Okay, it depends on length of the conductor, it depends on nature of the material. Okay, length, nature, and it depends upon area of cross section also. LNA. Okay, length, nature of material, area of cross section. Okay, the resistance factors are, remember my name, Lakshmi NA, Lakshmi Narayan. Okay, length, nature of material, area of cross section. Next, see, length L, here length double, length increases, resistance is directly proportional to the length. Resistance is directly proportional to length. Length increases, resistance also increases. And next, here look at the area, area A, here area is 2A, area increases, resistance decreases. It means resistance increases, area decreases, or area increases, resistance decreases. Why? Because if you take a street roads, how the area will be very small. If you take a highway, how the area will be more. That means if area is more, we can move freely, right? If area is less, no space. Okay, so area is less, more resistance will be. Okay, because collision will take place, I write. Area is more, less number of collisions. That means resistance is less. Next, and depends upon the nature of the material. Okay, nature of the material. That nature of material we call as that resistivity. Okay, see, R depends on L, depends on area. Remove the proportionality. In place of proportionality, you will get constant. That constant we called as that resistivity. What we called rho? What we call that rho? What we call resistivity we called. Okay, what we call resistivity. So resistivity is what? It's a material of the conductor. Okay, electrical resistivity is nothing but what? It's a material of the conductor. Which material you take? Okay, it depends upon the nature of the material also, right? If you take plastic, how the opposition will be. If you take wood, how the opposition will be. Okay, it's a resistivity of the material. Next, and unit rho is equal to RA by L. So area, how can we write? L into L na? By L. LL cancel. Resistance unit ohm. Length unit meter. So ohm meter is the unit of resistivity. Simple. Ohm meter is what? Unit of resistivity. Clear? Next. Yeah. Now look at that. Metals and alloys have low resistivity. Okay, which are having low resistivity? Metals and as well as alloys. Okay, alloys are nothing but mixed of metals. Okay, mixed of metals or mixed of materials. Mixture of metals or mixture of materials is known as alloy. So how the resistivity will be? Low. How the resistivity be? Low resistivity. Okay, how the resistivity in metals and alloys? Low resistivity. Okay, how much will be? 10 to the power of minus 8 ohms and 10 to the power of minus 6 ohms. This is the resistivity of alloy and as well as metals. How much? 10 to the power of minus 8 and 10 to the power of minus 6. Next, insulators. Insulators. So insulator nothing but rubber, glass, plastic. How the resistivity will be? How the resistivity will be? 10 to the power of 12 to 10 to the power of 17 ohm meter. How the resistivity will be? Huh? How the resistivity will be? See, resistivity means what? Opposition will be takes place. Okay, here free electrons, no free electrons are present. Okay, so I am taking a wood. I am taking a wood here. Okay, how the atoms and molecules gap is there between one molecule to another molecule, gap is there. Whenever, see, if for example, if I am taking at a temperature T, okay, I am taking at a temperature T degrees Celsius. If I am increasing the temperature, what happened? From the atom, electrons come out, na? From the atom, electrons come out. So if you increase the temperature, resistance decreases. Okay, why? If you increasing the temperature, number of electrons comes out. Electrons coming out. Okay, if an electrons comes out will be because of that amount of heat, it will flow now. Electricity will be there, right? Okay. Next, resistivity of an alloy is generally higher than of metals. How the resistivity will be? High. How the resistivity will be? I remember. Okay. Which one is having high resistivity? Alloys are high resistivity than metals. Okay. Next, see here we have few materials. Here you have few materials. Look at that, which is having high resistivity and which is having high resistivity. Look at that, which is having high resistivity. Which is having few materials are there, right? Look at that, examples of conductors, alloys, insulators. Okay, insulators which are there? Glass, rubber, plastic. These all are insulators only, na? And conductors: silver, copper, aluminium, tungsten, nickel, iron, mercury, manganese. Mostly all the metals are there in conductors. Okay, these are the values of resistivity of the materials. So you have to find out that which is having high resistivity and which is having low resistivity. How the resistivity will be? Okay, in different materials of conductors and in alloys also. Okay, alloys are nothing but is mixed of materials or group of materials. Okay, so which are present? Constant. Okay, nickel. Okay, constant means it's mixture of copper and nickel. Manganese, copper, nickel. Okay, so it's a mixture of materials. Alloys is nothing but mixture of material. Next, insulator. Glass, we know insulator is nothing but wood, plastic, glass, diamond. Okay, paper. These are the insulating materials. So see which is having high resistivity under. Okay, find out that from the table which is having high resistivity, which is having low resistivity. Look at those two only, because in a classroom we will focus on which is having more topper, which is having a topper and which is having low score. These two only, na? Even in the table also we will notice that which is having high resistivity value, which is having low resistivity value. Only two. Okay. Next. Yeah. Next. See. Look at a question. Look at a question. Read the question first of all. What given? What is the given information? Okay, if the question is given, don't worry. Write the given information. If you write the given information, half of the problem is solved. Okay, any question from the physics, any topic. Okay, so write the given information. If you write a given information, then you will get some confidence. Okay, I hear something, I know about this. Okay, then you know which formula you have to use and which way you have to solve the question. Okay, so just follow the class, you understand. See, a wire of given material having length L. So let us take a wire. How much length will be? I am taking given information only. Okay, what it is mentioned in the problem, I am taking that given information. So how the length will be? L. Okay, and area of cross section. Area of cross section. A is there. Okay, and how much resistance is there? How much resistance? Resistance of this given material is 4 omega. Okay, 4 omega. And what would be the, see, and what would be the resistance of another wire? See, up to here, let us take case 1. And coming to the second case, case 1, what is given? Given a length of the material, okay, resistance of the material, area of the material. And next, up to here completed. Next, what would be the resistance of another wire of the same material? Okay, material will be same material. If material is same, resistivity also same. Rho value is same. Okay, rho value is same because resistivity depends upon nature of the material only. Having length, see what changes takes place if this is L, another material is L by 2 only. Length reduces to half. Length reduces to half. And area of cross section. Area of cross section. Here area of cross section is A. Here area of cross section is 2A. Then, okay, what would be the resistance of another wire? Two wires are given, same material. One is having L, another one is having L by 2. One is having area A, another one is having 2A. Now see, what factors the resistance different? You know the factors, right? Just now we discussed. Resistance R is equal to rho L by A. This one in a formula. Rho value, same material, rho only. L, L only. A only. Here, this is take R1. R2. R2 is equal to resistivity rho only. Length of the material L by 2. Area of the material 2A. Then it will be rho L by A into 2 by 2. 1 by 2 into 2. 1 by 4. So rho L by A is what ma? That is the first material, right? So R2 is equal to R1 by 4. Then R1 is equal to 4R2. So comparing the two materials, R1 and R2, R2 having more resistance comparing with R1. Why? Same material na? Even same material also, resistance depends on what factors? What is my name? Lakshmi Narayan. Depends on length, depends on nature of material, depends on area of cross section. Okay? Yeah. Next, one more question. Why are alloys like manganese or constant are used for making standard resistors? Okay, making standard resistance, okay, rather than pure metals. What you are making here? Resistors you are making. Then pure metals. So pure metals means how that resistance will be low resistance. How the resistance will be low resistance. And here high resistivity. How the resistivity will be? High resistivity will be. High resistivity will be. So high resistivity will be. High resistivity means opposing more. Where we are using in resistors we are using. Where we are using? Alloys, where we are using? In resistors we are using. Why we are using in resistors? The two alloys we are using compared to the metals. Having any doubt? Why? Anybody from comment section? Why we are using alloys then the metals? Metals will allow easily, right? But here you have to identify making resistor. For making resistor. So what resistor do first of all? Opposing. Which one oppose more? Alloy or metal? Alloys are oppose more. Why alloys opposes more? Because mixture of metal. Whenever a mixture of material takes place, the order is in order. How the resistance will be? Right? High. How the resistivity will be? High. If resistivity will be high means temperature also increases. Okay, temperature also increases. If you take a heater, Okay, or iron box. How heat comes? Because of alloy. Because of alloy. Okay, you have high resistivity. If resistivity is high, the temperature increases because collisions are maximum number of collisions takes place. Temperature is increases more. Then if temperature increases, if I am taking iron box, if there is no producing of heat, what is the use to make? What is the use to buy iron box? No use it, all right. Okay, yeah. So what is the reason? High resistivity compared to the metals. Okay, understood now? Next, yeah, and summary. What we are going to discuss in today's section. Okay, just recap quickly. Okay, see, introduction of charge. Introduction of charge. Charge is what? Intrinsic property, where it is present inside. If there is no matter, no charge. Matter is present without charge also, but charge is never present. Okay, for example, without oxygen, I will not present. But oxygen is present without me, right? Is correct only, na? Huh? Yes or no? Oxygen is present without me also. But I am not present without oxygen, right? Okay. So, charge is present with the matter. Without matter, charge is never present. But matter is present without charge also. Next, conductors, insulators, semiconductors. Conductors means allow. Semiconductors means of allow. Insulators mean doesn't allow. Okay. So I have three friends. Three friends. First person I given 10. Second person taken 5. Next person, okay, in 10 I am taking 5. Insulators, it doesn't allow. Okay, semiconductors are, sorry. Okay, conductors allow. Semiconductors half allow. Insulator doesn't allow. Okay, next, electrical current. Amount of current passing through a given time. Charge passing per unit time is called electrical current. Okay, next, circuit. Circuit means it is a path. If I would like to go from one place to another place, from here to or Mumbai or Vijayawada or Hyderabad or any place, I would like to go by walk. No, na, I need a transport facility, right? So to move from one place to another place, charge also required circuit. Next, electrical potential. Potential means infinity. Okay, I am giving a shortcut here. Infinity to a point. Infinity to a point. Potential difference. Potential difference between any two points in circuit. Any two points in circuit. Okay, potential difference nothing but any 2 points. Potential means infinity to at a point. Next, circuit diagram. What are the components are there? What are the component? Resistor is there, variable resistor is there, okay, switch is there, open switch is there, closed switch is there, bulb is there, ammeter is there, voltmeter is there, ammeter connected in series, voltmeter connected in how? Anybody? Voltmeter how we connect? How we connect voltmeter? Huh? Parallel. Okay, yeah. Next, Ohm's law. What is Ohm's law? V proportional to I at at constant temperature. At constant temperature. Okay. Next, factors. What factors are there? What factors are there? If you are writing in the examination also, if they are asking about what factors the resistance depends, immediately you have to remember. Okay. What is that? Length, nature of material, area of the material. Okay. Yeah. So this is summary. See, in this section, what are the topics we're gonna cover? We're going to discussing with resistance of system of resistors. Okay. In today's topic, we're gonna discussing about resistors. Okay, in last class also we discussed about resistor. In today's section we are discussing about system of resistors. Okay, system of resistor or combination of resistor. In the combination of resistor, we have two types, series and parallel. Okay, what is mean by series, what is mean by parallel? So in already last session we discussed about what is series and what is parallel, right? Okay, what is mean by series? End to end connection. Like if you take a train, how the bogies are there? End to end connection is there, right? That is series. Okay, side by side is there, that is parallel. Okay, so end to end connection. Series means in shortcut end to end. Okay, end to end is series. And what about parallel? Take 2 points. X is 1 point, Y is 1 point. In between these 2 points, we take in number of rays. Okay, taken number. See, at x and y divided na. X and y, between x and y, we have a three paths. This is parallel. Okay, one by one, one by one, one by one. Okay, end to end series, one by one parallel. Okay, and next topic is that heating effect of electrical current. Heating effects of electrical current. And next, electrical power. Next one is what? Electric power. Okay, yeah. Can we start? Yes. See, resistors or in series. Resistors or in series means what? How it will be series? If you are taking a, for example, I am taking resistor here. One resistor. Another resistor. Okay, here it is end. Here it is end. Another resistor I am continuing. See, here it is end point na. This is the end point of a first resistor R1 and R2 connected to end point of first one. Similarly, at end point of R2, I am connected one more. So what is this? This is a series connection. What is this? This is series. So series means end to end connection is called as that series connection. Okay, end to end. End to end is called as that series connection. Okay, see, look it in the diagram. Look it in the diagram how R1, R2, R3 are connected. End point R1. This is the end point of R1. This is the end point of R2. This is the end point of R3. So resistors are connected one by one. Okay, end to end. End to end. End to end connected means resistor. How trail bogies are there? One after another, right? So that is resistors are series. Okay, if the resistor are series, how the flow will be? How the flow will be? This is a very important point. Okay, if the resistors are in series, how the flow will be? Look at the diagram, circuit diagram. See, what is this? This is battery. This is battery. Why it is battery? Number of cells. Okay, number of cells or combination of cells we call as that battery. From the positive terminal, the current is flowing. Where it is? It reaches ammeter, it passes ammeter, and it end here. Okay, it passes here at X. See how ammeter and how voltmeter is connected. Voltmeter is always connected in parallel. In last class also we discussed the same thing. How we connect a ammeter and voltmeter. Maybe there is a chance to asking about, okay, in examination, how voltmeter we connected in a circuit, how ammeter is connected in a circuit. Okay, remember, voltmeter is always connected parallel, ammeter is always connecting in series. Okay, ammeter is always connecting in series. Next, see at X point what happened? The flow is there. At X flow is there. See R1. What is R1? Resistor of the first. R2. Resistor of the second one. R3. Resistor of the third one. So resistance means what? Slow down the movement of an electron. Okay. What it do? What it do? It opposes the flow. That's it. Okay. Resistor means what? It opposes the movement of an electrons. Okay, if the electrons are coming this direction, opposing, okay, passes R1, again R2 is there. Okay, R1 passes, again R2 is there, R2 passes, again R3 is there. So how the flow will be? The flow is same at every point. Okay, how the flow is same. Flow is same. In which circuit flow is same? Which circuit the flow is same? In series the flow is same. What it is changes? Potentially changes. Okay, in a series circuit flow is remains the same. Potential is varying. Okay, for example, in front of me three speed breakers are there. Okay, apart from each speed breaker 2 meters or 5 meter distance is there. Okay, first I cross the speed breaker. When I crosses the speed breaker of first one, coming to the second speed breaker, I have same potential or potentially changes. Potentially changes. Potential changes na? And coming to third speed breaker, there also potentially changes. And what about my flow? Flow is what? Flow is reduces, but how the flow will be? Same only na? How the flow will be? Flow is remains the same. What it changes? Potentially changes. Okay, remember when resistors are connected in series, what it is same? Current is same. Current is nothing but flow is same. And what about a potential? Potential is varying from one resistor to another resistor. Okay, first one I cross with some potential, and coming to the second one, can I face same? No, right? Okay, for example, if I am playing a match, I have three matches: quarter final, semi final, final matches. Three matches are there. If I play quarter final, if I win, okay, and semi final also with the same potential, it's not possible, right? The potential is decreases now. Already completed one game, the potential is decreases, right? So here also when resistors are in series, what it is varying? What it is varying? Potential is varying. Okay, the same current through each resistor. When the current is same, when the resistors are connected in series. Clear? Next, see, resistors are in series. How the all the resistors are connected? For each resistor potential is there. V1, V2, V3. How the potential are connected? Potentiometer connected. How voltmeter is connected? Parallelly. Okay. How voltmeter connected? Parallelly we connected. See, here amount of current is enter here. Here amount of current is enter, and it passing like this. Current is flow is passing like this. What happened here? Potential is variated. How much potential takes place in R1? That potential we will calculate by using voltmeter V1. And after crossing the P, it is entered Q. R2, it is entering R2. At R2 also have another potential. That potential calculate at V2. Okay. And similarly at R3 have another potential. See, here current is I. If I is the amount of current is entering R1, R2 also same amount of current, no changes. R3 also same amount of current, and leaving the R3 also same amount of current. Finally coming to ammeter, same amount of current, and reaches here also same amount of current. So the current is remains same when the resistors are connected in series. Okay, what changes? What changes? Potentials are changes. Okay, so I would like to calculate total potential or net potential. Okay, total potential or net potential in the circuit. How much voltage is present? How much voltage is present? See, here voltage V1. Net potential na V net or V total is equal to total potential. How we can calculate? Adding up those potential, right? So V1 is the first potential, V2 is the second potential, V3 is the third potential, because potential only is varying. So if you want to calculate total potential means total potential V is equal to V1 plus V2 plus V3. Okay, total means adding. Okay, V1. So at V1, what is the V1? At V1, V1 means from the Ohm's law we take V is equal to IR from Ohm's law. From Ohm's law, what is the relation between these three? V is equal to IR. Okay, at R1, what is the potential? V1. So V1 means current is I only, resistor R1. At V2, current is same only, resistor R2. At V3, current is same only, resistor is R3. And total net current. Okay, throughout the circuit, what is the current? I only. What is the current coming out from the battery and reaches the battery also same amount of current. Okay, V I is the total current and resistance. Total resistance is series na RS. Total resistance RS. See, calculate I. Then what is the remaining? Total resistance RS is equal to R1 plus R2 plus R3. Okay, when you will get all the resistors are in addition, when the resistor connected end to end, it means series connection. When the resistors are connected in series, the equivalent resistance, the total resistance of the circuit RS is equal to R1 plus R2 plus R3. Or okay, or simply if you want to remember means, if you want to get the total resistance of the circuit resistance, check whether it is series or parallel. If it is series, add all. How many resistors are there? 3. R1, R2, R3. So add R1 plus R2 plus R3. That is the resistance in series. Equivalent resistance. RS is equal to R1 plus R2 plus R3. Okay. Next, resistors are in parallel. Next one is what? Resistors are in parallel. Parallel means what? Let us take 2 points. X is a one point and Y is another point. Okay. Between 2 points, we have number of paths. Different paths we take it. See, this is a one path. This is second path. This is the third path. Okay. Look at here. From the battery, current I is coming. How much current is coming from the battery? I is the amount of current coming from the battery. Up to point X only, the current is I only. But whenever, see here, how many paths are there? 3 paths are there now. So the current is split into 3 paths. The current splits into 3 paths. How many paths you given to flow of current, that many paths will be there. For example, simply see here, I am taking a one tube here. One tube I am taken here. And to this tube, I connected another two tubes. Another two tubes. Okay. See, here water flow is there. Water flow. Which flow? Water flow. Water flow. See, which direction the water flow is there? This direction also flow will be there. This direction also flow is there. Okay. If it is equal area, if area is equal, the flow will be same. See, here water is entering and at this point X it dividing into 2, the water flow. Okay, how we connected water. Okay, similarly, total calculate I or flow. Total flow is equal to flow of the first one plus flow of the second one. Then you will get total flow. Then you will get total flow. So here also what happened? 3 different paths are there. Then what it will be divided? Current will be divided. Okay, current is divided. Here it is I1, here it is I2, here it is I3. So current splits into 3 paths. If it is 4 paths are there, then it splits into 4 paths. If it is 5, divides into 5 paths. Okay, so what is the current is coming through the R1? I1 is the current. And what is the current is coming to R2? I2 is current. What about R3? I3 current is coming. Okay. Whenever current is divided, okay, the potential are same. What is the potential? Potentials are same. See, it takes, okay, see, I1 R1. Here potential I2 R2. Here potential I3 R3. If resistors are in parallel, okay, remember blindly, resistors are in series, flow is same, current is same. Resistors are in parallel, potential is same. Okay, when potential is same, resistors are parallel. When current is same, resistors are in series. Okay, so now potential is same now. Potential is same through each wire. Three wires, each wire 1, 2, 3. In each wire the potential is same only. And what it is divided? Current is divided. Then what is the total current? Total I total in the circuit is equal to I1 plus I2 plus I3. Okay, if you want to find out the total current, I total is equal to I1 plus I2 plus I3. Okay, total current, because current only na dividing. Initially what we taken, potential is divided, then total potential in the circuit V is equal to V1 plus V2 plus V3. But here potential is same, current divided. Then total current I is equal to I1 plus I2 plus I3. Okay, then from Ohm's law, V is equal to IR, V is equal to IR, then I is equal to V by R only. Then substitute total current, total potential by total resistance. Okay, if you want to get total current means total potential by total resistance. I1 potential, potential is same now. Potential is same now. Potential is same, right? Okay, so V by R1, I2 is equal to V by R2, I3 is equal to V by R3. So potential same, then cancel it. 1 by Rp is equal to, Rp means R parallel, resistors are parallel, 1 by R1 plus 1 by R2 plus 1 by R3. Okay, this is the formula for resistors are in parallel. Resistor series means addition, 1 plus 2 plus 3. Resistors parallel means 1 by R1 plus 1 by R2 plus 1 by R3. Clear? Yeah. Next, see current X divided 3 parts, I1, I2, I3. Okay, I1, I2, I3 divided. And what is the total amount of current coming? I is the amount of current. I is the total amount of current through the circuit. I is equal to I1 plus I2 plus I3. Next, yeah. Now see, solution. Look at the question first. Look at the question first. Okay. What you are observing in the question? The many students are facing an issue in the numericals, especially in the chapter of electricity, because they're confusing about potential and potential differences and all. Okay, and how the resistors will be. Resistors are series means which formula we have to take, which is constant. If resistors are parallel means which is constant. Okay, you are confusing. Yeah, see, I will explain how to solve the numericals in a simple way. See, first of all, read the question. How can three resistors of resistance? How many resistors are there? Three resistors. They only say three resistors are there. What are they? Did they mention any names? No. So we take it is that 2 ohms is R1, 3 ohms is the R2, 6 ohms is that R3. So we take in three resistors as per the question are connected. Okay, they are connected. R1, R2, R3 are connected. And if you connected, given a total resistance, so if you connected, it give 4 ohms, and if you connected 1 ohms. Okay, as per the question they given 3 resistors. Okay, if you connected these 3 resistors, one time you will get 4 ohms, And if you connected these three resistors, again you will get 1 ohms. How it is possible? Let us check. See, given for every numerical, the important one is the given information. Okay, given information. For the given information also marks will be there. So given, what is given? R1. Let us consider R1 is equal to 2 ohms, R2 is equal to 3 ohms, R3 is equal to 6 ohms. So three resistors are given. We are considered as R1, R2, R3. Now, if you connected these three, first you connected means how much you get? 4 ohms. How it is possible? How it is possible? How can we connect? I'm taking here, I'm taking R1 like this. Okay, R1, I'm taking like this, and here R2 and R3, or I am connecting like this. Okay, like this I am connecting. See, which are in series, which are in parallel? From the circuit diagram, tell me which are in series, which are in parallel. Which are in parallel? End to end. End to end. For example, I is the amount of current is passing. R2, R3. How this R2, R3? How the R2, R3? Parallel, right? Right? So, first I am taking a parallel. What is the formula for parallel? 1 RP is equal to which are parallel? R2 resistance and R3 resistance. 1 by R2 plus 1 by R3. So, 1 by R2 value 3. 1 by 3 plus R3 value 1 by 6. So, LCM is what? 6. 2 plus 1. 3 by 6. Then 1 by 2. Then the total resistance of R2, R3 combinedly how much? 1 by Rp is equal to, then resistance are parallel. 1 by Rp is equal to 1 by 2, then Rp is equal to 2. Okay. The total resistance of R2, R3 how much? The total resistance of R2, R3 how much? 1 by R2 plus 1 by R3. How much we will get? 1 by Rp will get. The value of Rp is that 2 ohms. Rp is the 2 ohms. These 2 ohms, how we connect it to R1? If you want to get 4 ohms, tell me anybody from comment section. The total resistance of R2, R3, I got 2 ohms. When I connected in parallel, R2, R3 especially connected in parallel, by the connection of R2, R3 parallel, I get the value is 2 ohms. These 2 ohms, how you connect it to the R1 to get the value of 4 ohms? How we connect it? Anybody from comment section? Anybody? See, they got an answer. Very fast, na? See, how they connected? If you want to get 4, already 2 ohms are there. If you want to get 4 ohms means, how we connect series or parallel? From the comment section, they give an answer also. For first one and second, how they connected? Series they connected. See, the total resistance of R2, R3, 2 ohm. Na? These 2 ohm, if you connected, okay, this is R1. This is R1. And to this R1, they connected RP value series. RP value. RP value how much? 2 ohms. R1 value how much? 2 ohms. Then the total value R1 plus RP is equal to 4 ohms only. You got na? You got it na? 4 ohms. So first one completed. And second one, the question is not completed yet. Okay. 1 ohms. How you get 1 ohm? Anybody from comment section, how you get 1 ohm? Huh? You got 4 ohms. How you get 1 ohm? See, here R1 is there. Here R1 is there. What is the value of RP? 2 ohms. These 2 ohms, if I connect it to the R1, the 2 ohms, if I connect it to the R1 parallelly, now calculate R1, RP. How these two will be? Both are parallel. Then what is the formula? 1 by R parallel 2 is equal to 1 by R1 plus 1 by R parallel 1. 1 by R1 value 1 by 2. 1 by R parallel value 1 by 2. Then 2 by 2. Then 1. Got it now, Announce? Very simple. Very simple. Clear? Yes. Okay. See how it is. Okay. Next. 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 In a circuit, three resistors R1 10, R2 10, 20, R3 30 are connected parallel to a battery of 12 volts. Okay. So as per the question, you have to draw the diagram for better understanding under. Okay. So see how I am drawing. Similarly, you try for other questions. Okay. Given what given? Three resistors are there. R1 10 ohms. Okay. R1 10 ohms. Next R2 20 ohms. R2 20 ohms. Next R3 how much? 30 ohms. R3 30 ohms. So I am taking R1, R2, R3. How they connected? Connected parallelly. Parallelly means take 2 points. X is 1 point, Y is 1 point. X connecting R1, R2 connecting X, R3 connecting X. Similarly, R1 connecting Y, R2 connecting Y, R3 connecting Y. Now all are parallel. That's it. Okay. Now current is divided. Okay. So to which one they connected? Connecting to the battery of battery. How much volt? 12 volts battery. Okay. See, through the 12 volts, how much current is coming? I is the amount of current is coming. And here it takes what happened? Current divided because three paths are there. I1, I2, I3. Three paths are there. Okay. And after passing R1 also, I1, I2, I3. So again here at point Y, all are mixed. I is the amount of current is coming again to the battery. Okay, this is the diagram. Next, what do you want to find out? Current flowing through each individual resistor. Okay, current find out through each individual resistance. See, we know, find outing a resistor. What are the variables are required? Voltage is required, current is required, resistor is required. Resistors are given, potential is given. So many are confusing at this point only. Resistors are given. You like to find out current in each resistor, and potential is given or not. See, potential is given. Yes, potential is given. The potential is same at every wire. Why? Because all are parallel. Okay, all are parallel. From the Ohm's law, V is equal to IR na. V is equal to IR. Now remember the formula of Ohm's law, because many numericals by solving based on the Ohm's law only. V is equal to IR. From that V is equal to IR, I am calculating that I1 is equal to V1 by R1. I2 is equal to V2 by R2. I3 is equal to V3 by R3. Simple. I1 is equal to V1 by R1, I2 is equal to V2 by R2, I3 is equal to V3 by R3. Here the common is what? Potential is common. Potential V only. R1 how much? 10. Potential V only. R2 how much? 20. Here V3 potential is V only. R3 30. Now calculate. 12 by 10. 12 by 20. Potential is same now because circuit is parallel. 12 by 30. See, 12 by 10. 12 by 10, 1.2, 0.6, 1.2 half, 1.2 by 20 na, 0.6. And here again 3, 12. Okay, 3, 0.4. Okay, 1 by 3 na, 1 by 3 into 1 by 10, 1 by 3 into 1 by 10. So 12 by 3, 4 times, 4 by 10, 0.4. So the total current means I is equal to I1, see, I1, I2, I3. Add all this, I1 plus I2 plus I3. How much I1? 1.2, 0.6, 0.4, 0.6 plus 0.4, 1, 1 plus 1.2, 2.2. So then I is equal to 2.2 amperes. Done na? The current flowing through each individual resistance we find out. I1 1.2. Okay, through the resistor of R1 how much? 1.2. Through resistor of R2 0.6. Through resistor of R3 0.4. We find out each individual current. Okay, next total current also we done. Total current I is equal to I1 plus I2 plus I3. In the circuit how much current is present? It means summation of all these three, I1 plus I2 plus I3. I1 1.2, I2 0.6, I3 0.4. Then adding all total current in the circuit by the 12 volts battery, how much? 2.2 amperes. Next, the question not yet completed. Total effective resistance. Effective resistance means R effective or R total. R effective or total. Total potential you know, total current you know, then current you know, potential you know, then easy to calculate the resistance of the circuit, right? Effective resistance, right? Anybody from the comment section? What is the formula we use? What formula we use to calculate the effective resistance of the circuit when they given about potential and total current? What formula? What formula? V is equal to IR, Ohm's law. See, V is equal to I or voltage 12, current 2.2, resistor don't know, that only we going to find out R effective. Then R effective is equal to 12 by 2.2. How many times? 2, 12, 5 na? 6, approximately 6 will be there, but 2.2 is there, right? Then 5.45 amperes. Okay, 5.45, 5 to 12, 5 to 10, 4.5. Okay, so 5.45 is the effective resistance of the circuit. Clear? Okay, this is the way to solve. Okay, yeah. Next one. In figure, R1 is given, R2 is given, R3, R4, total 5 resistance are given. Total 5 resistance. In examination also, maybe they ask you like this only to trouble you. Okay, but don't worry. Okay, here I will help you to how to solve this kind of problems. See, total resistance, how many resistors given doesn't matter. Okay, if you know the concept, resistor connected in series, then it is series only. Resistor connected one by one, parallel only. Okay, parallel is the resistors are parallel. What it is divided? Current is divided. Resistors are series, voltage divide. Simple. B is equal to IR. How the voltage, how the resistors, how the current will be. Resistor series, potential divide. Resistors parallel, current divide. So it completely based on the resistors. Okay, so focus on the resistor. See where it is connected, 12 volts battery. How they connected? Connected to the arrangement. Calculate total resistance. Again effective resistance only, R effective. Okay, and next total current. Two things we going to find out here. Listen, two things. What are they? Total resistance. See, two different resistors are given, right? in two cases. Here R1, R2, from the battery, I is the amount of current is coming. Look at this point, let us take it is X and this is Y. What happened? At this point, the current is divided now. Here it is going I1. R1, R2 are parallel. That means which one divide? Which one divides? Current divide. I1, I2. So current is divided. Okay. Through the R1, how much current is passing? I1. Through R2, how much current is passing? I2. So I1 is going to R1, I2 is going to R2. Okay. See R1, R2. Then if you calculate the total resistance here, 1 by Rp is equal to, for first one, first diagram, 1 by Rp1 is equal to 1 by R1 plus 1 by R2 na. So 1 by R1 value how much? 10. 1 by 10 plus R2 value how much? 1 by 40. 1 by 40. Let us take 1 by 10 common. 1 by 1 plus 1 by 4. Okay. 1 by 1 plus 1 by 4. So 1 by 1 plus 1 by 4, how much will be? 1 by 1 plus 1 by 10 plus 1 by 1 plus 1 by 4. LCM is how much? LCM is how much? 4 is the LCM. Right. 4 plus 1. 5, 4 plus 1. Okay. So 5 by 40. How many times? 1 by 8. So this is the first circuit of diagram. First circuit diagram RP1. Then RP1 value 8. Okay. So combining of these two resistors, what is the total resistance of R equivalent R effective of R1 and R2? How much? 8 ohms. Okay, we completed R1, R2. Remaining R3, R4, R5. How it will be? Again, the current is combined here. I is the amount of current coming. Here also I is the amount of current coming. But here through R3 again divided I3, again divided I4, again divided I5. So current is divided. Current is divided. Calculate the resistance of R3, R4, R5. Anybody? Anybody? R3, R4, R5. Calculate. R3. In parallel only na formula. 1 by Rp2. Second circuit diagram Rp2 value. 1 by R3 plus 1 by R4 plus 1 by R5. That's it. Only 3. Okay. Below 3 only na. 1 by R3 value 30. R4 value 20. R5 value 60. Take 10 common. 1 by 10. 1 by 3 plus 1 by 2 plus 1 by 6. LCM. LCM. 3 to 6 LCM. 3 to 6 LCM. बताओ. Tell me. 2 times. 12. Right? 12. 1 by 10. 4 plus 6 plus 2. Okay. Then 6 plus 4. 12. 12 by 12. 12 by 12 into 1 by 10. 12 by 12 cancel. Then 1 by 10. So this is the Rp2 value. Then Rp2 is equal to 10 only. Okay. The combination of these three, R3, R4, R5. So combination of these three, R effective is equal to how much? R effective is the 10 ohms. Okay. By the R1, R2 we get 8 ohms. By the R3, R4, R5 we get 10 ohms. So what is the first one? Total resistance. Total resistance. So how much total resistance will be? R total is equal to Rp1 plus Rp2 only. Rp1 how much? 8 ohms. 8 ohms. Rp2 10 ohms. Then totally 18 ohms. Simple. Simple. Total resistance in the circuit is 18 ohms only. The question is completed. Not yet. See, resistance we find. Next, total current. Tell me formula. Which formula from comment section? Which formula? Which formula from comment section? What is the formula? Resistance is given, that we find out total resistance in circuit. Current we are going to find out. Potential is given. So among these three, what relation is there? V is equal to I R. V is equal to I R only. V is equal to I R. From Ohm's law, V is equal to I R. What is the voltage? What is the voltage? Voltage is given. Yes, given 12 volts. 12 volts. Resistance. How much we calculated? 18. 12 by 18 is equal to total current. I total. I total is equal to 12 by 18. Calculate 12 by 18. 2 table 6, 9. Again 3 table 2, 3. So 2 by 3 is the total current. Okay, again if you calculate it 2 by 3, 0.6 something will come now, 0.6 ampere. That is the I total. Okay, the total current in the circuit is at 0.6. 2 by 3, 26 times 0. Okay, 0.6 ampere is the total current is present in the circuit. Clear? Next. What is the next topic? Heating effect of electric current. Heating effect of electric current. See, if you take any electronic devices, if it works continuously, what happens? Even like fan also, or bulb also, or any electronic devices like mobile or laptop, okay, TV, any electronic devices, it works continuously. What happens? It produces some amount of heat. Yes or no? We are already experiencing in a daily life. If you are using continuously mobile, after some time it gets heat only. So why it gets heat? Huh? Why it gets heat? See, a part of the source energy in maintaining the current may be current useful work. Okay, daily life without electricity is not possible. Okay, we will stay without friends also, but we cannot say without electricity in a daily life. Yes or no? Hmm? Yes sir. In comment section they giving yes sir. Without friends also we will be there. Without mobile phone also we are not there. Yeah, because we are happy to. Okay. See, yeah, useful work. So which work we are doing? Rotating a fan. Rotating an electrical fan. How the electrical fan works? Because of electricity only, na. Otherwise, some person will be there rotating with the finger. No, right? See. So rest of the source in the form of heat. Okay. For example, I am taking a one battery here and I connected to the bulb. So some amount of current is passing through the bulb. Then the bulb glow. After continuously working, what happened? From the bulb only, I get some amount of heat. Why I get some amount of heat? Through the bulb. I am given electricity. I am not given any heat. But heat comes from the bulb. Why? Because what the bulb doing? Doing a work. What kind of work? It produces a light energy, right? Because it continuously working that light energy, it gives some amount of heat. How the heat comes? The resistance. Because of resistance, if it is having more resistance, more amount of heat it is produces. Okay, see, rises the temperature of the gadget. Why the heat comes? Temperature of the gadget rises. If I am using continuously mobile phone, allow temperature rises na. Okay, for example, an electrical fan in a daily life we experience that only, which are the electronic devices we are using in daily life, those all are producing a heat. Okay, yeah, and produces a warmth. continuously for long time. If it is in continuously long time, what happens? Produces more amount of heat. This is called as that heating effect of electrical current. Simply heating effect of electrical current means if any electronic device, any electronic devices continuously work. To continuously work means what required to work? First of all, electricity is required. This electricity is not giving to work. Okay, it produces some amount of heat by the device also. The process we called as that heating effect of electrical current. Okay, heating, not eating. Okay, don't keep H silent. If you keep H silent, eating. Okay, heating effect of electrical current. Okay, if you keep the silent of H, heating effect of electrical current. What current heat? Okay, so heating effect of electrical current means what? If you use any device continuously, it produces some amount of heat. This process is called as that heating effect of electrical current. Simply, if you, in the examination, if you not remember means, look at the fan. Continuously work. To work continuously, what required? Energy is required. Okay, the fan is continuously working means from the fan also you'll get some amount of heat. This total process we call as that heating effect of electric current. Understand? Yeah. Next, see, power. Okay, the power input to the circuit by the source. How much power? How can we calculate power? Okay, there is a bench here. I am pushing the bench. I am doing work on the bench. Okay, how can I calculate the power? Power P is equal to work done by time. Okay, work done by time. For example, there is a one box here. There is a one box here. I move the box from A to B. A to B. I moved a box. For moving the box, I am taken 10 seconds of time. For moving a box A to B, I am taking time of 10 seconds. So I completed my work in 10 seconds. And another person is came. Okay, another person is came. For example, Bahubali came. Bahubali came. Bahubali came, applying a force here, applying a force here. He completed the work in 1 second. He completed the work in 1 second. Who is more power? How can we calculate the power? How can we calculate the power? I also did the same work. Bahubali also did the same work. Who is more power? How can we calculate the power here? How can we calculate? Who takes a less time? I am taking 10 seconds from A to B. Bahubali takes just 1 second. Fraction of seconds. Okay, within 1 second, it moved from A to B. Okay, who is having more power? Bahubali is having more power than me. Okay, see, if you take out the power and time, inverse. Out the power and time, inverse. If time increases, means power decreases. Time increases means power decreases. Time decreases means power increases. Simple. I am taking less time, I have more power. I am taking more time, I have less power. Okay, so power is equal to work done by time. So, what is the relation between work done and potential? What is the relation? In potential, we discuss na V is equal to W by Q. Then W is equal to VQ. Substitute here VQ by T. So Q by T, again I is equal to Q by T na. So in place of Q by T, substitute I. So power P is equal to VI in terms of potential and current. P is equal to VI is the formula in terms of potential and current. So P is equal to VI. Next, the energy dissipated in the form of heat only, that we know. Okay, if any device works continuously, electronic devices, it produces some amount of heat by the steady current. Okay, remember the term steady current. Steady current means the flow is same. If I turn on the tap little bit, water is coming, each drop, how that flow will be same, right? So if you connect it to the battery also, from the battery the current will be steady, means remains same. same flow will be there. Same flow will be there. Okay, and the amount of heat produces in time of t is that. For example, the fan is continuously working. Okay, continuously working, it produces heat. How can you calculate that amount of heat? How can we calculate that amount of heat? See, H is equal to H is equal to VIT. Okay, heat. H is equal to VIT. It's a product of potential, current, and time. Or else write heat producing per time. That is equal to VI. That is equal to power. Okay, heat produces per time. If you use continuously, okay, I am using a one company fan. You are using another company fan. Okay, another company fan produces more amount of heat in a same time. Who is having more power? Time taken less, power is more. Okay, H is equal to VIT. H is equal to VIT. The amount of heat produces in the given component means how can we calculate? Potential and current and time. Okay, product of potential, current, and time. Joule's law of heating. Joule's law of heating. So, what is the Joule's law of heating? If any device, okay, any electronic devices works continuously by the electrical current, it produces a heat. That is called Joule's law. Okay, how much work it do? Okay, how much work per time? That only na power. Okay, work done per time. See, an electrical fan is there, it's doing more work. The fan is working or any electronic device is doing more work per time. That is power na. More work per time. Work done per time. Power. See, work. So whenever the work is done, it produces a amount of heat H by time. So energy per time. In place of work done, I am writing energy per time. For doing any work, what required? Energy is required. How much work is done, that much amount of heat produces, right? If I am continuously thinking brain, amount heat generated. No? No, just casually. Okay. So if continuously working means heat generated. If continuously riding a bike, work is going on. Because of that work only heat generated. So work in place of heat time replaces. Okay. H by time. That is equal to power. Power is what? Power is equal to VI. Na? Power is equal to VI. Na? So work done by time is equal to VI. Or H by time is equal to VI. So H is what? Amount of heat. Then H is equal to VIT. Okay. This is called Joule's law. Okay. So Joule's law. So see, I am writing that VI. Okay. VI. VI. So what is I value from the Ohm's law? What is I value? V is equal to IR. Then I is equal to V by R. Na? Substitute here. V by R. Then it will be V square by R. P is equal to V square by R. P is equal to V square by R. Or if you required in terms of current, P is equal to VI. Then substitute V value. V is equal to IR. Na? IR into I. Then I square R. So you get two formulas. In terms of current, you have I square R. In terms of potential, you have V square by R. Okay. So see here, directly proportional to the square of current for a given resistance. See, heat produces H is equal to H by T na. H by T is equal to Vi na. Vi, how can we write? I square R. Okay, then T will go this side. I square R T. Okay, then H is equal to I square R T. This is the Joule's law. Okay, H proportional to I square, H proportional to resistance, H proportional to time, H proportional to time. Current is square of the current. Okay, increases, heat increases, resistance increases. See, if I'm taking one resistance here, if I'm taking one more resistance here, where the heat will be more? First one or second? Second one automatically, because resistance is more. Okay, collision will be more, then heat will be more. Okay, more amount of heat it produces where? If more resistance is there, high resistance is there, high amount of heat it produces. Okay, and time taken, time increases, amount of heat also increases. Okay, H is equal to I square RT. Okay, H is equal to I square RT. What we called Joule's law of heating. Okay, remember the formula. H is equal to I square RT. Okay, can we go for next one? Yeah, see, an electrical iron is there. How much resistance is there? 20 ohms. Okay, write the solution. Given information. What is the given information? What is the given information? An electrical iron is given. Okay, resistance of electrical iron, resistance of iron is equal to 20 ohms. Okay, fine. Takes a current of 5 amperes. How much current is passing through that iron box? How much current? I is equal to 5 amperes of current. Okay, fine. Calculate the heat. Calculate the heat developed in 30 seconds. Time is also given. 30 seconds of time. What do we want to find out? H value we are going to find. Based on this, you have any formula? You have any formula? You have any formula? Anybody from comment section? Any formula? You know that? Based on I, based on R, based on T. Have any formula? Do you know? Anybody? Huh? See, just now we discussed na Joule's law of heating. What is the Joule's law? H is equal to I square or T na. I square RT. I value 5 square, R value 20, T value 30. So 25, R value 20, 30. 225 is a 50. Okay, 5 into 30 in 3 into 100. Okay. Next 25. 2 into 25. 2 into 25, 50. Okay, zeros, one more zero. So 15,000. 15,000 is the amount of heat generated. Okay, amount of heat 15,000 joules, some amount of heat is generated. Okay, 50 na? 1 zero added here. 225 is a 50. 1 zero added here. Already from this 0 and this 0. Total 3 zeros. 5 3 is a 15. 15,000 of joules is produces in a 30 seconds of given time. Okay, I am using an electrical iron working how much time? 30 seconds. In this 30 seconds of time, the 15,000 of joules of heat is produces. Okay, yeah. Next, practical applications of heating effects of electrical current. What are the practical applications are there? Where we use practically? If you take iron box, it produces amount of heater produces amount of heat. Okay, many electronic devices produces the amount of heat which we are going to use for heating purpose especially. Okay, boiling egg, heating only. Induction coil heating only. Okay. Cooker heating only. So many electronic appliances are there. Okay. Electric heating is also used to produce light. Electrical heating we are using for producing a light also, because if I am taking a filament, so the filament gets heated, then only it produces a light. Then only it produces light. Okay, if filament gets heated, then only it produces a light. So it has high melting point. Okay, high melting point. Tungsten, see how the melting point will be 3380 degrees Celsius. This much is there. Okay, melting point is very high. Melting point is that very high. How much? How much melting point of the tungsten? 3380 degrees Celsius is the melting point of the tungsten used for filament. Used for filament. See, 3300 degrees Celsius. Anybody get doubt why we are using this much temperature? If the temperature rises, it produces more amount of heat. If more amount of heat is there, then it gives light. Okay, if any material produces heat, means it will be releases more amount of heat. Okay, next, the bulbs usually filled with chemical inactive nitrogen and argon gases along the life of filament. Okay, which are the gases we are using? Inorganic nitrogen and argon gases are we are using in a bulb. Okay, next, yeah, another common example Joule's law heating is the fuse. Remember the word fuse. Okay, nowadays we are using MCB, miniature circuit breaker. Switch on, up, on. Okay, shock laga. Okay, see, fuse. Okay, the symbol of fuse is like this. The symbol of fuse is like this. This is the symbol of fuse. How we connected? How we connected fuse? Fuse always connected in a series. Remember, in MCQ they have a chance to ask you how fuse is connected. Always series. Okay, yeah. So why we connected? Protecting the circuits. How we connect? How we connected? It is protecting the circuits. Are we connected in series? And what is the material it made up of? Metal or an alloy? Okay, an appropriate melting point. What is the material we using? Can we use plastic, wood, or any other material? No, we will use metals. We will use mostly, or an alloy we will use. Okay. For example, metals, aluminum, copper, iron, lead, etc. Next, if current larger than specified value flows through the circuit, the temperature of the fuse wire increases, then it melt the fuse and breaks the circuit. For example, switch on off, switch on off, switch on off. Have you seen these things? Okay, switch on off. For example, I'm taking a switch here, on off, on off, on off. What happens? If continuously on off means what happened? If continuously sit and stand, sit, stand, sit, stand. If continuously doing means what happened? It affects on your muscle, right? So similarly, if continuously on off means the potential difference will be high. So it cannot take immediately. So that's why what happened? It breaks the circuit. Okay, this is the reason if continuously current is come and go means in a home, they said that all the electronic circuits will be stopped immediately. Why? Because of it creates high potential difference. Because of this high potential difference, the electrical components doesn't work. It fails. Okay, maybe circuit problem or any other issues electronic devices will come. Okay, so if potential difference will comes means it breaks the circuit and the fuse protect that electronic device, because fuse is what? From through the fuse only it passes electricity. When the fuse breaks, what happened? It doesn't pass electricity through other components, right? So the remaining all electrical equipments are safe. because fuse taken high melting point. Okay, it breaks the circuit. If circuit is break, how the electricity passes through it? It doesn't passes, na? Okay, yeah. Next, the rate of doing work is called power. Rate of doing work, P is equal to work done by time. That we already know it. Okay, and P is equal to VA. Also, we got the same formula. Okay, and how we connected that? SI unit of electric power is what? Remember the word. Watt. Okay, watt. So what is that? Watt? Electric power. If your teacher is asking question, what is the unit of electric power? What is the question? What is the unit of electric power? What? What? Answer is there. What? Okay. What? What is the unit of electric power? What is the unit of electric power? Watt. What is the unit of electric power? Watt. Okay. Yeah. See, the power consumption by devices that carry 1 ampere of current when operated to potential difference of 1 volt. P is equal to VA na. P is equal to VA na. When you will get 1 watt of power, 1 watt of power, LHS is 1, that means potential is 1. Okay, that means potential is 1. That means potential is 1. Potential is 1. Current also 1. Then you will get 1 watt of, you will get 1 watt of power. Okay, when you will get 1 watt of power, potential is 1, current is 1. Then you will get 1 watt of power in a circuit. Okay, next, the commonly unit of electric energy, common unit of electrical energy is kilowatt per hour. See, which is that? Kilowatt per hour. Okay, kilowatt hour is the unit of energy. It's a common unit. Kilowatt hour. Okay, so kilo means how much value? Kilo means how much value? 10 to the power of 3. What is what? It's a unit. Okay, it's a unit. Hour means 3600 seconds. That means 3.6 into 10 to the power of 3. 2. 3.6, 10 to the power of 6 will come. Or 36 into 10 to the power of 5. Okay, so 1 kWh value is this much. Okay, 3.6 into 10 to the power of 6 joules. Okay, 3.6 into 10 to the power of 6 joules. This is the way calculating. 3.6 into 10 to the power of 6 joules, or 36 into 10 to the power of 5 joules. Anything you take it. Okay, what is the kWh? It's a common unit of electrical power energy. Okay, na? kWh, kilowatt hour. Kilowatt hour. Kilo, 10 power 3. Hour. How many seconds are there? 3600. 3600 seconds are there. Okay, next. Yeah. So, out of two bulbs, one rated 100 volt, 220 volts, and other is 60 volt, 220 volt. Which one has higher resistance? So, which one has higher resistance? Here two bulbs are there. Two bulbs are there. First take the given information. Two bulbs are there. What are they? First is that 100 watt bulb. It is connected to 220 volt. And second one is that 60 watt bulb. That is also connected to 220 volts. So the potential of 60 volt, okay, the potential of 220 volt is same only. Okay, see, first I am taking 220 volts, 220 volts, 220 volts only. Okay, connected to bulb, the bulb glow. So how much? 60 watts. Okay, and another one, another one you take, another one you take. Here also 220 volts only, connected to the bulb. How much? How much? How many watts? 100 watts. So which is having high resistance? What are you going to find out? In this, apart from these two, which one is having high resistance? So what is the given information? Power of the two bulbs are given, P1, P2. Okay, and voltage is given. Voltage is given na 220 volts. What are you going to find out? In these two, which is having high resistance. So what is the relation between power, voltage and resistance? Power, voltage, resistance. So what is there any formula based on power, voltage, resistance? P is equal to VI na. This is the formula, right? This is the formula. We required in terms of voltage, power and resistance. So here there is no resistance. Substitute the value of resistance from the Ohm's law, V by R. Then V square by R. Power P is equal to V square by R. Power P is equal to V square by R. So in a both the circuit, how the voltage will be? How the voltage will be? Same only. So take V square is constant. Take V square is constant. Then P inversely proportional to 1 by R. Okay. If resistance increases, power decreases. Power increases, resistance decreases. It means what we required? Power we know. We don't know resistance, right? Then R inversely proportional to 1 by P. R inversely proportional to 1 by P. If power is more, resistance is less. If power is less, resistance is more. Okay. So compare now two bulbs which is having more power. Which is having more power? 100 watts. Okay. Power is more, resistance is less. Power is less, resistance is more. So which one is having more resistance? Anybody from comment section? Anybody from comment section? No need to calculate because the potential is same. No need to calculate. So find out the relation between power and resistance. Anybody from comment section? Yes. 60 watt bulb. Because 60 watts, power is less, power less, resistance will be high. Both are inverse. So 60 watt bulb has more resistance. Okay. 60 watt bulb more resistance than 100 watt. Okay. Next. In a house. Okay. Next question. See, there is a house. In the house, 560 bulbs are there. Okay. I am taking one bulb, two bulb, three bulb, four bulb, five bulbs. Okay. Or else, or else, or else, five bulbs are there. Okay. Five bulbs. So I am taking one bulb. What is that? 60 watt. Okay. Power how much? 60 watt. Like this, five bulbs are there. Okay. Like this, five bulbs are there. Five bulbs are there. 5 or 60 only. Okay. 5 or 60 bulbs only. Next, are used for 5 hours. How much? How many hours they use it? For 5 hours. Okay. I am taking a bulb. From first 2 hours I am using the bulb only. Similarly, 5 bulbs I am using 2 hours. So in their house, 5 bulbs are there. How much time they are utilizing these 5 bulbs? 5 hours daily. Okay. And each day 5 hours. Today is 5 hours. Tomorrow 5 hours. Day after tomorrow 5 hours. So each day 5 hours daily. Okay. Next. And two heaters also. Two heaters also. What is the power of them? Power of them P2 is equal to power of the heater is equal to 1000 watts. 1000 watts are used for time. Here time is that 5 hours. Here time is for T2 is equal to 2 hours daily. Daily. So bulbs also using daily, heater also using daily only. Calculate total energy consumed in a month of 30 days. Okay. So daily they are using. daily. Okay, in a month 30 days are there. For these 30 days, how much energy, total energy for 30 days? Okay, and cost of the rate is per unit. Per unit, how much? 4 rupees. Per unit, 4 rupees. Okay, per unit, 4 rupees. See here, kWh, kilowatt per hour, is called as a unit. Whenever kWh is there, you can use 1 unit. Okay, that means 3.6 10 to the power of 6 joules na. Okay, kWh value we use for 1 unit. kWh is there 1 unit. Okay, kilowatt power, commonly known as unit. kWh called as that unit. Now see here, how much? 5 hours, 60 hours. Okay, calculate the total energy. Calculate the total energy. Total energy is equal to 5 hours daily. Daily 5 hours. How much power? 60 watts. How many days? 30 days. Okay. Just a minute. Okay. So 5 hours. 5 hours. 60 watts. Right? How much? 5 hours. 5 into hour. Convert into 60. 3600 into 60. 3600 into 60. Okay. Converted hour na. Per hour 3600 seconds. Okay. Each day. How can we calculate? Power is equal to work done by time only na. Power is equal to work done by time. 60 watts. It is given a 60 watt time. What you going to find out? Energy of the total 5 bulbs. Okay. 5 hours. 5 hours. 5 hours. 5 bulbs. Each bulb having 60 watts. Calculate. 25 into 60. 6 into 10. 625 sir. Okay, I am taking kWh only because finally I will convert into kWh value converting into unit. Okay, so instead of taking 3600 1 kWh value, I am converting into unit only. So 5 hours, 5 hours, 5 bulb, each bulb is that 60 watt. Then 6 into 25, 6 into 25, 150, right? 150. Then 10, 1500 means 1500 by 1000. 1500 by 1000, that means 1.5 units. 1.5 units only by bulbs. Okay, 5 bulbs continuously. Okay, 5 bulbs continuously used means how much? How many units? 1.5 units. And coming to the heater also, 2 hours. Okay, 2 hours daily. How many heaters? 2 heaters, each one 1000 watts. It means 4000 by 1000. Okay, because I'm converting into units. Converting into units. So 4 units. This is E2. E2 is 4 unit. E1 is 1.5 unit. E2 by the heater I will get 4 units of current because you know, right, if you are using a heater, because of heater get more electricity, more amount of heat is generated, then more work, more energy is required. Okay, so that's why whenever we are using a heater, then the current bill will be high. Observe it, whenever you are using a heater, at that particular month the bill will be high. So because it takes more amount of heat is required. So for heaters, two heaters only 4 unit of current, but 5 bulbs 1.5 units only. Then total means E net is equal to, total energy is equal to E1 plus E2. E1 how much? 1.5. e to 4, totally 5.5 units of current. Okay, this is for one day, only for one day. Total energy in a day 5.5 units. Then 30 days, 5.5 into 30, so 0 point cancel, 55 into 30, 165. Okay, 165 units, 165 units in a month of 30 days. In a month of 30 days, how many units amount of energy? 165 units. Okay, and each unit cost is 4 rupees. Now the problem is not done. Okay, for each unit 4 rupees. How many units are there? 165 units are there. Anybody from comment section calculate and tell me 165 into 4. 165 into 4. Calculate. For each unit 4 rupees. Okay, so then 165 units means 165 into 4. 4 16 are 640. 640 into 4 5 is 20. So 660 rupees. 660 rupees is the bill only by this. 660 rupees is the only bill by using 2 heaters and 5 bulbs. Okay, yeah, clear na? Next, summary. Okay, so let's recap very quickly what we discussed in today's section. The resistance of system of resistors. Okay, so system of resistors is nothing but combination of resistors. How the resistors will be. Okay, when series end to end connection, end to end connection is there series. When it will be parallel, step by step. Okay, step by step. That means one resistor by another resistor by another resistor. Okay, step by step, parallel. Heating effect of electrical current. If you use any electronic devices, it produces some amount of heat. That is called heating effect of electric current. In the heating effect of electrical current, Joule's law is there. What is that Joule's law? H is equal to I square RT. H is equal to I square RT. H proportional to square of the current, proportional to resistance, proportional to the time period. Okay. Next, electrical power. How can we calculate power? Work done by time. From this work done by time, we will get P is equal to the relation with the potential and current. P is equal to VI. Okay. In terms of potential, P is equal to V square by R. Okay. And in terms of current, P is equal to I square R. Okay. When the potential is constant, if you want to calculate the power and resistance, if the potential is constant, power is more, resistance is less. Power is less, resistance is more. Simple. Okay. See the relation among them. Okay. Yeah. That's all for today. I hope you all enjoy the class. Okay. Let's meet in another section. The same energy and same joy. Okay. Have a nice day. See you soon. Thank you all.